Okay, we're going to continue looking at some examples of exponential functions. So here we have the U.S. population was 281 million in 2000. The population increases at an annual rate of 1.24%. Write a function that models the U.S. population growth in millions after 2000. Use this function to predict the population in 2020 round to the nearest million. So first of all, A is our initial value is 281. R is our our rate, which needs to rewrite as a decimal, which means you have to move the decimal place 2 places to the left, 0.0124. T is the time in years, and from 2020 to 2000 is 20 years. Once we plug into each of these variables, we end up with 281 times 1 plus 0.0124 to the 20th power, which gives me 359.54, which is approximately 360 million. Women's basketball tournament involves 64 teams. After each round, half the teams are eliminated. Write a function that determines the number of teams left after each round. How many rounds are played to determine the winner of the tournament? Hint, what is R when t equals 1? Set up a table. So here's a table. At the very beginning, even before round 1, there's 64 teams. After round 1, there's 32 teams because 32 have won, 32 have lost. After another round of games, 16 move on, 8 move on, 4 move on, 2, and then the final match results in the winner, which is 6 rounds. Now, you can build a function by using sort of the generic exponential function template. Okay, so we have a times b to the r power. And I'm using r because r is going to be the number of rounds. R is the input value. A is the starting number, which is 64, and b is the rate of growth or the rate of decay. In this case, it's the decay rate by half, 0.5. So there's your answer. 64 times 0.5 to the r power. And just for the heck of it, if we plug in 6, you would also get 1, because that's how many teams are left. The exponential function a equals p times 1 plus r to the t power gives the amount in an account when a principal p is invested at an annual rate of r and compounded once a year for t years. So in part A, you have $1,000 to invest at 6% interest, which we must move the decimal place 2 places to the left, 0.06, and we need to have a time of 5 years. This is pretty straightforward. We plug it in. We end up with 1,000 times 1 plus 0.06 to the 5th power, and we round this to the nearest cent, $1,338.23. We're not going to do part B because we don't really know how to solve for t yet. All right, so we'll be getting to that next lesson. And number 4, I wanted to introduce to you E. E is a special. It's a number. It's an irrational number. It's you can access it by hitting the second function ln button. As you can see, it sets up e to the x. So E is a very common base that we use, especially for problems that involve continuing compounding interest. So the formula is A equals P e to the RT. A is the amount of money in the account. P is the initial investment, which in this case is $750. R is the interest rate, which in this case is 3%. And the time in years is 8 years. Plugging all this into our formula, then into our calculator, 750e to the parentheses 0.03 times 8 close parentheses you end up with $953.44. Ladies and gentlemen, there's the lesson. It's more practice because these sort of problems just take practice to really master. Best of luck to you.